Hello, I'm Harrison Her, and today I will be going over my arc length project for AP Calculus AB at the Bergen County Academies. So first I will be going over what exactly I measured using the arc length method. I measured the track field of my old middle school, which is a place I like to go to when the weather is nice to go for a jog. However, the problem with this was that I didn't exactly know how much I was running. I didn't really have a way to calculate how many laps I needed to run to have run a mile. And so throughout this presentation, I will be showing how I utilized the arc length method to um, calculate how many miles I should run for approximately a mile. So this is just a quick sketch of the track being split into different components. As you can see on the sides, the side lengths are each 326 feet across, and because I do not know the length of each arc yet, I have labeled these arc 1 and arc 2 for the time being. So in order to determine the total length of the track field, I will need to multiply the length of the sideline by 2, as well as multiply the arc length by 2, and then multiply those two values together. So at the moment, I have the first half, I have the numbers for the first half, but uh, this project will entail calculating the second half of this uh, formula. So this graph just shows the important points that will be used later on to calculate the quadratic regression. As you can see, there's 4 points: 0, 0, 79, 0, 101, 139, 101, as well as 218, 0. And uh, I was able to find these points using the measure tool in Google Maps. And as you can see, the yellow line, which is basically uh, outlined by these white lines, which you can't really see because I covered them with the yellow lines, but the white lines were used for the track. I mean, not for the track, for the soccer field. And I basically outlined this white line using the yellow line to see uh, how long the middle section is, which came out to be 60 feet. And once I found out that the second point was 79, 101, I simply added 60 to the x value of that point to come out with 139, 101. So in order to find the quadratic regression, I used the graph program, which allows you to enter various points, and the program will generate the quadratic regression line formula for you, quadratic regression equation. And to do this, I simply inputted the 4 points and came out with this equation. Uh, and in the first image, you can see the quadratic regression equation, and in the second image, you can see kind of a visual representation of the 4 points as well as uh, the quadratic regression line that comes with it. And it was helpful for me to kind of visualize all of the um, points and its relation to one another, as well as the model line that kind of connects all of them together. So the derivative of the quadratic regression came out to be negative 0.0184 times x plus 2.0051. And because the base formula to calculate an arc length is an integral from a to b of radical 1 plus the derivative of x, uh, the derivative of f of x squared, I simply substituted those numbers for the values that I retrieved previously, and came out with 322.871938 feet. And using the equation that I came up with earlier, I just simply input these numbers and come out with 1,297.743877 feet, which is essentially the total length of the track field. And in conclusion, as a conclusion, I will need to kind of answer my original question of how many laps should I run to run approximately a mile, and the answer to this is approximately four laps, because if I divide 5,280 feet, which is the length of 1 mile, by 1,297.743,877 feet, which is the a length of the track field, I get 4.068599 laps, and hence I will need to run approximately 4 laps in order to run a total of 1 mile. Thank you.